Consider the organic compound X, this compound X, with the following structure. The complete oxidation of X gives what? This X is propan2-ol. That is propanol, whose OH is attached to the second carbon. So, what would be the oxidation product? Is it propanol, propanoic acid, propanone, or propene? So, let's go. What this question is trying to test is your ability to know the oxidation of different classes of alkanol, of the primary, secondary, and tertiary. So, if you want to know the difference between primary, secondary, and tertiary, you can watch the previous video. Now, this is a primary alkanol because the carbonyl carbon, the carbon having OH has at least 2 hydrogen atoms. So the oxidation is just adding oxygen to this compound. What oxygen does is to remove one hydrogen from OH group and one other hydrogen attached to this carbon to form water. And we now have RC, double bond will be established here. This hydrogen is where it is, and this is the first step. Why did I call it first step? Because there is another hydrogen attached to this carbon. Therefore, there could be further oxidation. This further oxidation leads to formation of RCO OH here. This O joins this H, and we have OH here. This double bond O remains there. This compound having this functional group CHO, remember the functional group CHO. This is a functional group of alkanol or aldehyde. Why this one having COOH functional group is called alkanoic acid. So, primary alkanols can be oxidized to alkanal, and further oxidation leads to alkanoic acid. This two-step reaction is possible because there are 2 hydrogen atoms attached to carbon. This is secondary alkanol, having only 1 hydrogen attached to carbon. Therefore, the reaction must be one step. What is the one step? Oxygen is added. Remember, there is loss of water here. There is loss of water. So, we have loss of water here because this oxygen picks this hydrogen and this hydrogen. And we have R, C, double bond O, and R. The hydrogen is lost. If you check this, you will see that there is a CO functional group, which is functional group for alkanone or ketone. There shall be no further oxidation because this carbon has no oxygen again. Here, this carbon, this is tertiary alkanol. This carbon has no hydrogen. So when you put oxygen there, there will be no reaction. No reaction. So what we are going to consider in these options is which of them is this structure a primary alkanol? Is it a primary alkanol, secondary, or tertiary? Primary alkanols must have this carbon having 2 hydrogen atoms. Secondary must have 1 hydrogen atom. Look at it, this is secondary alkanol. It has only 1 hydrogen atom. So there should be first step reaction. And this first step reaction produces alkanone. So the correct option will be, the product will be, let me write the product. The product will be, if we have this reactant, OH, CH, H, H. If we have this reactant and we want to oxidize it, what this oxygen does is to collect this hydrogen and this hydrogen to form water. And what is the remaining? H, C, H, H, C, double bond O. C, H, H, H. You see it? Now, if you check this, it has a functional group CO. And this functional group is alkanone. alkanone functional group. Therefore, there are 3 carbon atoms, prop, propane, then one, propanone should be the product. So the correct option is C. Although in that WAEC past question, they said is B. The correct option is C.